And that maybe will bring an end to license wars, I suspect not. Test. What can we do to test it? Well, we can do wonderful things to test it. Because we can control how two working nodes connect together, we can, for example, set up 100 pairs of answering machines. We're two answering machines, we have talk to each other, and we have 100 instances of that, and they're each talking to each other, and they talk to each other, and then you close them down and you see how it works. So we can do unit testing of the answering machine on its own without everything else going on. So we can show that the answering machine is robust. We can do unit testing of the conference utility on its own. We can set up quite mean tests. We can set up the conference utility so that thousands of nodes or workers are created and they're destroyed, create, destroyed. You can set up thousands and thousands of these per minute, per hour, whatever your pathological nature so desires. And you can get it right. You can show that it works. And then when you go out to deploy it, you go, well, I know it works. I've beaten the living daylights out of it. And you know what? The end result is that it is simpler. Now, at this point I'm going to stop and say, but what about an IVR? How do I set up an IVR in this environment? Well, an IVR is an interesting case. The call comes in, you direct it to an answering machine. They press the DDMF button and they say, I want to go to a conference room. So you move that worker node representing the call coming in to the conference room. They press another DDMF and you move them elsewhere. So you move that incoming call around. So in that sense, you can build an IVR out of the components that we have here. It means that the controller has to have the knowledge and ability to do IVR functionality. It does mean that you don't have to have an IVR module that can do play and record, and then separate modules which do play and record. We only have one instance that does play and record. The controller is a fascinating little beast. As I said before, you can make a GPL. You can actually have multiple controllers active at a certain point in time. One is always concerned when I say multiple controllers, but if two controllers are active and they operate on different calls, so what? What is the problem? Provided none of them try to talk to the same worker node at the same time and give them instructions, then we have a recipe for disaster. But you set your controllers up to operate on different calls in different sectors, if you like. No problem, we can have lots of controllers. A controller will be any language, it can be any license. You could write it in Python. And Python's my current package. You could write it in C if you want, Perl, Lua, and all it's got to do is send and receive TCP messages to the server. That's all it has to do. As I said, it could be in Python. The GUI, you could build your Python into a GUI, and you can actually set up a very quick and easy GUI for an application, for a VoIP application. The controller is going to be asked to do many weird and wonderful things. So let's write down, when we think about it, it should be extensible. I have said it should go do a Fourier transform. Why not? Once we set down the requirement of it can do that, and we think about the ability to do a Fourier transform, then we raise the bar, and it is, we ensure that we don't get left with a product that can't do very much. Let's add functionality. It should be configurable. Well, of course it should be configurable, because you never know what it's going to be used for. I mentioned at lunchtime, OpenHV3 had a letter to the mailing list a while ago, and they said, you have an ini file, synonymous to the Windows ini file, and you specify variables, variable equals something else. And the person said, it's a bit limited. I'm giving it 2,000 character string, and it won't fit that into your ini file. I really think that it's not good enough. And we were like, 2,000 characters? What are you doing? And he said, well, I'm storing images in there, and it should work. All right. So we fixed it. And that's what we're going to be faced with. People will ask it to do weird things. It should be cross-platform. Of course it should be. As I said before, that is one of the simple methods of testing multi-threaded, weird little applications. And it is a defence against that repeated message to the list. Why can't I run your code on Windows? People want to run on Windows. All right, let's accept reality. They will. We'll live with it at the design time. We'll work with that. Logging. We can do wonderful things with logging if we set it down at design time. If we think at design time of what we want to achieve, then we don't have to bodge in logging at a later date and have an unacceptable product. Call accounting is something that they want, and that's relevant, pays the bills. Yep, I'll accept that. I'm working at the moment on a generator. I've spent some time writing Python scripts to do the testing, and it was a bit of a mission. I'm not a Python man. I'm working on an automated thing to generate Python control scripts. I appreciate your talk, RJ, this morning on CCXML, and that will be one way of doing it. You are correct, there are many more web programmers in the world than there are phone application programmers. I would suggest, though, that flow diagrams of the sort that I will be using here are much more understandable than XML. There is a greater chunk of the population that can cope with that. Yes, it doesn't look a lot at the moment. I've got to work on it. In that diagram there, I show you that there's a for loop, there's a bit of Python code executed in the middle, and it does actually work. And you start and end processing at the top and bottom. Now, demonstration. I said, as any PBX should have, there should be a demonstration. You are quite correct, there will be a demonstration. It is a demonstration on reality. There is no way I am travelling halfway around the world with one suitcase and then doing a demonstration. One never does a demonstration in a talk. You will, so that's my view. You will also know that you are, I also know that you are developers, and you know smoke and mirrors when you see it. And you never know when a guy does a demonstration of two calls connecting together, whether that is reality or a pre-recorded answer message that he's got running set up on his laptop. So you had your demonstration of reality. I quite like that demonstration. Right, that's the website, www.sofaswitch.org. Today is the release announcement. The code and docs are available on that site. There is, of course, full API documents there. I doxygenate everything. For me, 3 lines of doxygenation per method. That's about right. 4 or 5 is getting quite good. There is a lot of documentation there. The wonderful thing about doxygen comments is that it makes the project a lot longer, a lot quicker. It really does increase the number of lines in the project. That's reasonable, isn't it? And that, I believe, concludes my talk. No, it doesn't. Key things to remember. Tony, I appreciate your input in this project, inspiration and ideas and thoughts, and putting it with me, making these stupid comments on the conference and thinking about things. Appreciate your input in having this conference and getting it together. Thank you. Brian, I always appreciate your effort, and you know, the problems, email Brian, no worries, he says, I'll get it fixed. Internet Technologies, I'm very grateful to my employer for sponsoring my work. They've been a real blessing. Sangoma, of course, thank you for putting on this conference, the chance for me to come along, publicise what we've got. Thanks also to Doug for helping out. I really appreciate you guys. And maybe you better use Sofa and get some return benefit. Thank you. That concludes my talk. Does anyone have any questions? Do you want to go back to any slides, any comments? Sofa Switch, good question, Luke. Sofa Switch and Free Switch are both in some ways similar and quite different in other ways. They're both born out of the frustration of what we have at the moment is not good enough, it's not reliable enough. Let us have something that's far more reliable, let us raise the benchmark. The key difference between the two is that Sofa is designed from get up and go to be distributed, so you can put Sofa on multiple boxes and it will run on multiple boxes. However, there is synergy between the projects and there's a lot of excellent work that Tony has done. I suspect, Tony suspects too, that there will be a Chan Sofa set up so that Sofa code can use Free Switch and Free Switch to Sofa. Of course, they can be linked together. They're both MPL. There will be no license issued. They're both written.
Transcends the whole idea of the software with the software. That's the logical.
Can you get a mic?
Where you can actually.
You have the opportunity to involve all telephony-related equipment and projects into the SOFA concept because it gives you, if you're familiar with trying to use asterisks, sometimes you'll use, say, AGI and manager at the same time because you want to do both. And it's kind of kludgy to do it that way and it ends up getting stuck a lot of times. It's a layman way to put it. I don't want to go start over with another speech about it, but it's kind of, it gives you an opportunity to control your stuff with the script from far away when you might not be interested in anything besides what happens when the call happens. You don't want to know about telephony. You just want to write a little program that says, like, send the call here when this happens. And what you're controlling should make no difference. So we've proven by both working on two different ends of it that when FreeSwitch is ready, it'll be able to plug in right alongside his Opal instance, and as well other projects like Asterisk and Yay could be integrated. It should be remote controlled by this entire concept as a whole. It's like a logical PBX almost is a good way to put it, I'd say. And I think it'll come in really handy for people.
Are there any other questions?
Sure.
Yeah, I'm just, I get a sense, which is really good, that you were very interested in making sure that FreeSwitch and SOFA are complementary to each other in whatever way possible. Would you say, because one of the things that I see a lot of and seems to come up is a lot of folks are looking at a switch from a perspective of almost a carrier's perspective, if you will, and others are looking at it from enterprise perspective. Now, when you look at the underlying technology, I think the desire is to bring it all together, but would you say that one might lean more in one direction than the other? Is that even a fair question to ask? You know what I mean? Where one's sort of more of the underlying switching, whereas the other's more focused on the application side of things.
The demarcation between those two, or the different users, is unclear. You're talking about the carrier, the enterprise, and the small office, home office, and the home answering machine for a private individual.
Okay.
You could use that sofa in the home answering machine environment. Everything runs on one machine. It is designed to cope with the high integrate because you can scale out to multiple boxes. You'll have to write a new control module for it to cope with failover and so on. But the FreeSwitch will definitely work in the small office, home office, and the home case. They're both written by pathological people when it comes to coding. It has to work. There are two approaches to coding. The code is correct until proven faulty, or the code is faulty until proven correct. Tony and I take the second approach. And once proven correct, we agree that we argue it's not correct, and we think it's, and I think that answers your question.
It kind of is. It's not a fair question at this meeting.
Sure.
It's prognostication, right? So.
Another thing to add to that could be, okay, I'm going to keep the suspense because my FreeSwitch talk is tomorrow. So I'm not going to waste any of my material, so I'll have nothing to say. But I spent a lot of time just talking with Derek about how things ought to be in a way that make more sense. And I wholeheartedly consider FreeSwitch a component of SOFA Switch more than an alternate comparison to it. It's, to me, FreeSwitch is capable of being one of the things that you can control with the SOFA Switch overall approach. You'll have the controllers lined up, and the FreeSwitches will be done. They answer the calls, and they report to his controller, and it's going to give me commands, and I'll have an interpreter to do that. Now I have multiple missions. We converged at one point. We not only come from different countries, but we use different languages and coding and different approaches. So we can collaborate on our ideas verbally, but when it comes to actually doing it, we're day and night. So we both work on our own end of the same idea, and they will eventually fit perfectly into each other.
But that's one of the nice things. He's using C in APR, all right, and it's going to integrate beautifully into my C++ PWL. No worries.
Yeah, that is.
And And that's what it should be. And one of the other sad things that happens is you come across, sorry, I'm fixing showing, you come across another step. I'm going to call it whatever, all right? And you go, I'd love to use whatever in my application. Well, it's going to be a bit of a mission patching it in because this and linking, it's going to be a mission. Instead, with the sofa module, I come along, I put on the supervisor thing, I put on the worker thing, a few TCP sockets, 2 UDP sockets, and I'm done. And it can be proprietary. It can be and then I'll link it to MPL. Fine. All power to us. This is what software's about. We're working together.
What level of parallelism is there between your protocols and what there is now in like the CCXML call control stuff?
I won't answer that question because I don't know the answer. There are issues there, and I quite like many of the features in CCXML, and there will be talk with RJ afterwards, and I know he will talk with me. He better, please, and I'll be able to answer that question later on.
Yeah, one of the other things about CCXML as well is an XML environment, but there's definitely a lot of room for some very good, some digital tools to design stuff. That's kind of why that. What it is, state machines can be sort of hard to code by hand. Or there's definitely some
They're a mission.
Yeah.
Which is why I went to the flowchart, and underneath the flowchart it generates state machine orientated Python. And this Python's simple. And I'm like, no, I can't work, but it will. Because that for loop works, and it's like, oh, that wasn't hard.
We'll definitely be we'll definitely be talking quite a bit after that. So.
But as I said, the code's available, it's www.sofaswitch.org. Thank you, Tony, for setting up that website. Thank you, Justin, for doing the work, getting it up and running. Appreciate that. Did a good job. Justin sent us email, Justin, can you get this flipping site up, please, and just put this information? Oh, no worries. A few questions, and it was done. All right, I think we'll be able to move on. Yeah. We go to the Thank you.
Thanks, Dave. Thanks for that. Actually, we're going to now have one of our lightning talks, and can I actually get Nathan Smith to come up and talk about the state of the Open PBX project for 5 minutes? That'd be great. Thanks.
I'm Nathan Smith. Some of you might know me from online as Spackle. I'm right now the project leader for the OpenPBX.org project. I tried to think of a way that the OpenPBX.org could be an acronym for dead horse beaters, but couldn't figure anything out. Some of you may have some disdain for us for forking asterisk. I think this crowd will be a little bit more receptive. I think we've actually led to some improvements in Asterisk itself. At least they're switched to SVN and some other tools like that. Why we forked? There were a lot of issues. Don't get Tony started on. Control of the project, more contributions from GPL people, and waiting for free switch to be done. Our philosophy is to improve the stability of Asterisk, so everything we do is about stability. We're happy to have stability and forsake some features. And standards compliance and scalability where it doesn't interfere with the other things. We're close to announcing the 0.2 release. We've been on the cusp for about 6 months now. A lot of people are using it in production, having good success. we have a lot of contributors, but a lot of them are on the other side.
It should be open source. It should be reliable. Yes, it's a reasonable requirement. We have our name on the product. Engineering Technology Startup Communication Firm. We don't want the product to fail. And it looks bad when it fails. So yes, we will demand that it's reliable. The communication is over a radio network, so packets will be lost. That's the nature of radio. So it's harder on the VoIP system. So this VoIP system had better be reliable. It makes it quite hard to do billing if it's not reliable. Billing is an important thing to get right. Yes, I think we better argue it's reliable. Have any of you guys noticed a pattern that has to be reliable? Should have. It really has to be reliable. This is a fundamental requirement of any software used in the business world. It has to be reliable. It is beyond belief that product is sold that is not reliable. I do not know how they do it. That's their choice. So we look around. What do? Oh, join another project. That's a recent thing to do. They've written a whole bundle of code. I'm sure we can use that. Well, there are some bugs there. We'll fix those. Yeah, it shouldn't be too hard. Maybe we'll get some of those requirements. Yeah, maybe. It's possible. Bit of a learning curve when I joined that other project. You know, and the docs aren't very good. Remember my comment yesterday about, you read the online docs and comments, and the function is called set buffer depth, and the document says, the comments on that method says adjust the buffer depth to desired value. There's incomplete stuff like that. And this is going to make it hard to learn. It's unfortunate. And then we start looking around a bit further. And we see that functionality is copied, add infinitum. I do not understand the need to copy functionality. The copy and paste button works just fine on 2 lines, it works fine on 3 lines, and I'm sure it works fine on 1,000 lines, but you don't need to test it on 1,000 lines. For example, if you look in Asterisk, you will see that there are multiple jitter buffers. There is one in the SIP channel, there is one in the RDP channel, there's one in the EGS channel. This is ridiculous. Write it once, use it everywhere, make certain that it works. This desire to duplicate functionality is going to add to the size of the project, it adds to the number of lines to maintain it, adds to the number of lines to create. Forget it, let's get rid of duplication. It's kind of hard to test these multi-million, 1,000-line functions. How do we test them? Remember when you went to university, they said, when you have a function, you should create a harness for it, and every function has to have a harness, and you test every function in this harness, and maybe you can prove that it is correct. That's quite unfortunate, because in a threaded environment, you can write a test harness for a function, but you cannot show that it will still work in that harness as opposed to in the application, where there are lots of other threads running. It's not a good look when you come across a project and you see comments to the web list. We changed X and now something else is broken. What does that mean? Well, what's going on here? Surely they know the code. They've been in it for 10 years. Why break when X was changed? I don't know. Is this a sign of a badly maintained project, a badly organised project? If the maintainers of that project can't do this, what chance do I have when I join the project and endeavour to help fix it? Now, we all know that the number of bugs is set at design time. That is one of those software things. And we look at how frequently these bugs are being fixed. What's the frequency of these bugs being fixed? And if there's still a flat line, there's no decrease in the rate of bugs being fixed, then obviously there's something wrong. There must be a lot of bugs in there. What's happening? I don't know. And then we go back to this notion of being distributed. Well, we need to be distributed, and how easy will it be to push this change into those projects? How many email wars will I have to fight on their public mailing list? How bitter will they be? How receptive will they be to change? I don't think so. Let's move on.
all right, I'm sick of that. I think it's going to be easier to start again. That's unfortunate. I don't like, I've complained about them duplicating code, now I'm duplicating code and writing a new project. Yes, it's those hard decisions that one makes in deciding to start a new project. And I don't believe those existing projects that are around will meet our requirement. So we come up with a new project, and yes, I have been busy and I've thought of lovely little acronyms, and we're quite lucky there's quite a few vowels in there, so it's not too hard to come up with new names. And I quite like Sofa Switch. It has a notion of comfortness, and it is one of the goals of the project that you will not get pricked by weird little things in this project. It'll be a comfortable ride. That's the goal. Tony has contributed the very nice logo of the two penguins sitting on the sofa. At the moment, the majority of development is done on the Linux box. And as we do more development on the Windows environment, we'll have to add a wee Windows flag and maybe a wee devil in the middle. What's the Mac symbol? Whatever. An apple, yes. Yeah, an apple, a couple of apples on the sofa. So, move along. Well, what do we do? How do we design this new project? I had previous experience with the PWLib and Opal projects. I talked about it yesterday. If we choose to base our code on them, it sets the pattern where we're going to go. It sets the pattern that we should really be C++. It sets the pattern for a highly threaded environment. And it will, if we choose to use PWLib, it will make, and Opal, will make the integration of our code with VoIP really, really easy. Yep, I think we'll go that way. The other view on the choice of language is maybe another language is possible, but well, I know C++, I know it, it works, it's easy. Yep, that's what we use. And that is really what the choice of language boils down to at the end of the day. What do you know? What are you comfortable with? All right, go with it, use it. We are going to be highly threaded. There is no way around that. I explained yesterday that PWLib and Opal are highly threaded, and there are very good reasons for that, no good reasons. So yes, our project will be highly threaded, and that is the end of the story. And are we going to be moving those threads? No. So what happened? So we said, all right, we've got our goals, we know how we really want to start. Now, what do we do? It was around this time that Tony Minnesota in the site, we spent days and weeks and months in conference talking about what do we want to do. We were both quite frustrated with the state of the open source PBX options. There was nothing that was workable. They all had quite significant issues. We talked and we talked. This is one of the key requirements of designing quality software. Talk about what you want to achieve, what is the right way of doing it, and then talk some more. It is very easy to talk for a day. You can cover a lot of areas. It is so easy. You see software developers, they go off and they start coding and they code and they code, and then they go, oh crap, that was the wrong thing. And then there's 3 months of work that you've got to delete. And then they say, oh, well, I'm not going to delete that, so we'll box that into our project. No, we're not having that. So Tony and I, we talk and we talk and we talk and we talk. There are, in our view, 6 key elements in a PBX. The first element, I will call it an element or an application or whatever you want to look at, is a messaging system. There is some form of control that travels from one entity to another. We were drawing little pink boxes and blue boxes, and what are the key objects in a system? There must be something that will do voice record and voice play. It was with sadness that we noted that that voice record and voice play was duplicated over and over in aspects. That's unfortunate. There should only be one instance of voice play and only one instance of voice record. If there are 2,000, that is 2,999 too many. There should be something to do conferencing. That's relevant. People want to talk. People want to share ideas with others. There should be some form of VoIP access. There should be some form of telephone access. Something to link to your Sangoma card, to your Digium card, to your whatever card. And there has to be one entity to do the control. So we drew these little boxes and we said, all right, that's what we want, these little boxes. So what we're going to do is we're going to make each of those a separate application. And they can run on 6 separate boxes, or they can run on one box with 5 or 6 applications running. This will be quite good, we thought. It will allow us to test a card on its own, so that you can test a Digium card with nothing else running. It's just Digium software running, and we will find out for once and for all if that card is any good or not. We haven't got there yet, but that's where I want to go. One of the key realizations that we made in this discussion was that media and control should be separated. There is no, it was with sadness that we noted that in the asterisk system, when you list the currently available calls and you do that over a dial-up connection, everything slows down. Why is that? Because the media and the control are combined in the asterisk system. All right, we'll learn from their mistake. If the control process has to worry about media at the same time, doesn't it remind you of the juggler with 2,000 balls being held up at the same time? Isn't it much easier just to hold 1 or 2 balls and juggle those as opposed to lots and lots of balls? Let's reduce the complexity in the control system and just worry about control principles. And in the media side, just worry about media. I have 4 young children, and I have read Winnie the Pooh. I don't know if you're familiar with the quote. I'm a bear of a very small brain. That is what I feel at times when I look at this complex code. However, let's make it simple if we can. And so we are going to separate the media and the control. That is important. Inside our applications, that is our voice over IP systems, our TDM system, our conference system, our answering machine, our audio play, audio record system. There are 2 distinct entities within that. There is the supervisor and there is the worker entity. I mentioned yesterday, I talked about micromanagement, where your boss wants to know everything that you do. He wants to know when you go to the toilet, what you had in your lunch, when you go home. He wants to read every line of code that you write. He wants to know, that's ridiculous. Your boss doesn't need to know those things. And this is one of the key principles in SofaSwitch. The boss does his job and the worker does his job. So the supervisor is responsible for each application. I'll explain more about that here. The supervisor's job, he will create individual voice circuits. An individual voice circuit is, the operation of it is not the supervisor's worry, it is the control module's worry. The supervisor creates and shuts down the application. The supervisor should not be worried about those itty little bitty details. It's not his business. He will report on status. We're busy, we're not busy, we have, and so on. The worker module does not know anything about status. We're not going to duplicate functionality. That's a recipe for code bloat. Code failures too, but it's not true. So that worker, he manages one voice circuit. That worker will also direct audio to a specified IP address. He doesn't care where the audio goes, it's not his worry. He is told to send it there, fine. We don't want to spread the control from the control box into the supervisor, into the worker. No, it's much simpler. The only person who knows about control is the control module. The worker, if he's like, for example, a VoIP module, he will direct internal audio to a specified address and he will also make the call to the outside VoIP destination. Now, to illustrate this, because it's a sort of a circular problem, what is the controller, how does the command work? I'm going to illustrate it first with the command. So the controller will send a message to the VoIP supervisor. Please create for me a worker. That message will go out on TCP. The VoIP supervisor will respond with an ID. In the meantime, the controller will send a message to the answering machine supervisor and it will say, please create for me a worker. That message will come back also. And then the controller can then say, he was told that VoIP 23 was available note. Please call to h23.voxgarcia.org
and then you'll send a message to VoIP 23, that VoIP worker, send your media to the created answering machine node, that was the answering machine 28. And that way we create a VoIP call that is glued to the answering machine, which will record and play back audio. What are the format of these control messages? We talked about this. I really like the Jabber approach. Well, Tony did too, he's quite right. It's very simple. You have one ID and you send a message to a server. The server worries about destination TCP addresses, it worries about the TCP connects. When you, the controller, send a message to someone else, fine, just send a message off to the controller, from the controller to the message server distributes it where it needs to go. They're simple text messages, easy to follow, easy to devote. That will work. And we quite like the Jabber idea. The difficulty we found with Jabber, and we ended up dispensing with it, is that Jabber had this nasty little habit of, once the volume of messages got too high, it said, oh, forget this, and I'll delete some messages. It had this load reducing functionality, not very popular. As I said, the media is over UDP. It will connect to workers. The media does not go through the controller. The controller doesn't need that hassle. So that the media will go direct from the VoIP application to the answering machine application. It will go over UDP. There'll be some media loss, I suppose, on the LAN on the building or on the local network. I wouldn't have thought it would be significant. Now, if you want to do native bridging, you know where you have I'm going to talk about native bridging in a minute because there's a beautiful diagram coming up in a minute. The media, in one sense, can go via UDP, but if, for example, the answering machine is talking to itself with media, fine. It can do it any way it wants. It's not that doesn't matter as long as it talks. Yeah. So here's the example. The solid black lines, you will see 5 boxes there. There's the control at the bottom left, the server bottom middle, the answering machine at the right, the conference server SSMCU in the middle, and the sound box at the top left. The sound box is a simple sound card. Alright, connecting those 5 black boxes, there are the solid lines with the 4 dashes between. Those are the control messages. You will see inside the conference box, the answering machine box, the labels SSMCU and SSAM. That is the supervisor for the conference server and the supervisor for the answering machine. Within those boxes you'll see SSAM2, SSAM1, those are the worker nodes for the answering machine, 2 of them. Within SSMCU you will see 3 boxes, SSMCU1, MCU2, SSMCU3. Those are the worker nodes for a conference server, and then you'll see the hexagon with the word room on it. So, you see that the controller can send messages to SSMCU2. Those are control messages that can send messages to each of those individual identities. You will see that the SSAM2 is connected to SSMCU1 via a dash line, that's media. Similarly, AM1 is connected to MCU2 by a dash line, that is audio, that is media. MCU3 is connected to sound by media also. So what do we have there? We have 3 nodes in a conference. 2 of them potentially playing and recording audio. 1 of them is a sound card, and we're listening to what's going on in the conference. So we can see audio being played or recorded in the conference. We can test the conference. Now that setup can be run on 5 boxes or 1 box. It's irrelevant. It will scale. So what license? Well, this is the fun part. We have these applications, the conference, the answering machine. They are all currently MPL. But if you so wanted, you could make you could write your own controller and you could do it GPL. And there'll be no contention, there's no issues. Everything is connected over sockets, no license issues with Richard Saul, we're very happy about that. And that's fine.
We've got Bartek Kanye over in Sweden, and Massimo Cetra over in Italy, and Steve Underwood in Hong Kong. He's replaced all of our DSP functions, all the asterisk DSP functions with span DSP. And Michael, what did I just say Mike's last name? Bileki? Sorry, Mike. I know. That's why I said I'm sorry. And of course, we've got Tony and EKW to thank, and Mark Coinard. A lot of this spawned out of frustration from last year, and those three kicked off the project. We've done a lot of improvements, or what we think are improvements. We run as non-root. We think that's an improvement. We've got timers added, so if you've got real-time Linux kernel, you can get away from some of the Zaptel stuff, some of the Zaptel dependencies. The replacement of all the DSPs with span DSP. Tony replaced AskDB with SQLite for us. We've got an improved universal jitter buffer, so what Derek was talking about with all the replication of jitter buffers, we have a single jitter buffer. And then we've also had a jitter buffer donated to us by SpeakUp.nl, let's see, from Florian Overcamp, so we've got a better jitter buffer, we think. And then we've got intelligent call distribution that was added by Michael and his crew. Our ISDN support, which would be heavily favored by the people who are overseas, has kind of been delayed. So that's kind of what we're waiting on for the point 2 release. Doesn't look like it's going to make it in. And we're still heavily asterisk based, so you can still see your favorite things like avoiding deadlocks if you try really hard. We've got some exciting fax support that Lee's going to talk about later, but we have T38 support. And let's see, we're still here, and we're still working on building a more stable asterisk. Any questions? openpbx.org, kind of like openoffice.org. It's kind of non-trivial to get it installed because of the span DSP library, but we'll soon have at least Debian packages and maybe RPM soon too. Yeah.
We've been using OpenPBX quite heavily, and Nathan's actually submitted quite a few patches. They're in the bug tracker on there right now. And I mean, we've even gotten the thing to run inside a Zen domain. And I mean, we've got, you know, maybe 10 or 20 of these things running on a single box in a hypervisor. And we tried the same thing with Asterisk, and it miserably failed.
Yeah, that's been one of our successes, running OpenPBX in a VPS or a Zen or a VMware facility.
The especially noticeable thing about that was without Zaptel, the difference in behavior was one of totally unusable to production usable. At least as usable as ever gets.
So the elimination of Zaptel helped a lot with a lot of basic features.
Yeah.
There's still some reliance on it in some aspects.
Are you guys doing conferencing sans Zaptel at this point, or?
We have included the app conference. I can't remember the author's name.
Steve
Yeah, Steve's app conference. But we don't have anything more than that right now.
There's some talk, I think out yesterday, that there's quite a lot of blocking that did a lot with complex of weird. And I've seen that before. Do you have any thoughts on refactoring, rewriting parts of the code base? What are your thoughts on the big mission, if you like?
We're taking it a little bit at a time. You asked if we're reformulating the whole asterisk core because it's very complicated and has that giant loop in it. We're just taking it a little bit at a time. As we come across big problems, we hammer on them for a while. And we've had some good success with like the threading. We've had a oh, we added the generators. Carlos Mantunas did that. And so that helped with our dependencies too on Zaptel. Yeah.
Be willing to real-time trial avoid those what we call frame slips on Zaptel, but they're not really frame slips. It's just because they couldn't get the resources from the device in time, so there a slip happened. Is that what the intent was there?
It was mostly, yeah.
Did it address most of them?
I think so. I mean, that's why they're able to run in Zen and VMware.
So in your cases back there, you were running perhaps on a shared IRQ or something with the Zaptel card?
No Zaptel card at all.
Oh, no.
You won't just rely on it.
Are you guys using the 2.6 kernel too?
Yeah, you have to with that.
What happens sometimes is if you have a Zap card, and it's, especially if you're sharing an IRQ with something on that card, you can't, for some reason, you don't get all the audio, you get skips in the audio, you get empty range. And so it comes through as silence, and it really screws up fast.
I think there's some people online that can help you with that.
I don't need help with it, I just wondered if it's right there.
Bartek.
All right,
Tell them more
I'll
about
bring it up in my
Anyway, openpbx.org if you need a better asterisk than asterisk, check us out. Yep.
Yeah, I'll go ahead and do mine. I just put together some links people can use.
Thanks for that.
Thanks for that, Nathan. We've still got a few more minutes to kill, so we've got another one of our 5-minute speakers. And we've got Jason Garland, who's going to talk about a little toy that's been shown around a lot here for the past couple of days by a few people. And I'm the one who urged him to basically get up and talk about the Boost GPS mobile phones, which are available for $50 and seem very, very hackable. Oh, it's intensely good. Just a quick one. Is Martin Steinman here?
Yes.
Great. Okay. Sure. We're going to do some lightning talks tomorrow morning as well. So if there are anybody else who'd like to submit a talk, or just come and see Brian or myself, and it's 5 to 10 minutes, open, free for all. It's a good way to engage the community here.
Okay. If you go to aries.jasongarland.com/tilde/jgarland/gps.html, I put together some links on some of the tools that you need in order to turn one of these phones, it's a Boost Mobile prepaid cell phone, into an inexpensive tracking device. The phone is a Nextel iDen Motorola i415 phone. It's about $50 at Walmart, Best Buy, Circuit City. And with a USB data cable, you can load applications on the phone that utilize the GPS to send your coordinates over the internet. Internet service through Boost Mobile is 20 cents a day for unlimited internet. Very cheap internet service for a mobile phone.
Also, you can write your own applications in J2ME.
Yes. The application, mologogo.com, you can download a J2ME application that uses the GPS on the phone to upload your coordinates, their website, as well as your own website you can insert into the phone instead of a CGI script.
What was that URL again?
For my links,
Yeah.
it's right up here on the top. Let me see if I can
I
see it.
can't see it.
Oh, it's up here. Just go to Aries, A-R-E-S, the Greek god of war, I guess it is. jasongarland.com/tilde jgarland/gps.html.
Actually, Jason, if you could email that to me, I'll send it up to Brian, or
Okay.
you can email it to Brian and he'll post it out.
Sure. And then on the MoloGoGo site, let's go ahead and look.
But you can set up alerts, like if you're within someone's feed or something, and you tell you. Like, whoops, the wax coming home.
You can actually, in the application, you can set up a friends list. I've got a few people on my friends list. Whenever I want to locate them from the phone, I can pull up my list, and it'll show me where they're at. I just pick them on, locate so-and-so, and it shows me where they're at in the map and how far away they are from me, and their last known location.
So it doesn't, you can't actually draw a map of where they've been that past day, as they walk around the
You
city?
can do that. Actually, I've done that. I set up my own CGI script that the phone posts all the data to. It's like just a CGI script. It sends a post, and it sends the coordinates, the cell phone strength, the coordinates of the tower, the battery level, the signal level, the altitude, your heading. All this information is posted to a CGI script, and you can then store it in your own database server, and then write your applications to it. And some of the ideas were, Opus had an idea. There's a cell phone database that has all the locations of all the cell phones. And as you're driving down the street, you want to make it so all the cell phones ring, or the payphones ring as you drive down the street.
Well, you could write, a very intelligent follow me for that, with that.
Okay, and there's to load the software on the phone, you need about a $10 data cable. You can order it online. There's two types: one that charges the phone while it's plugged in, one that doesn't. And then you also need a program called WebGL. It's actually a real headache to install. Opus got installed on his laptop after about an hour or two yesterday.
Did that work on Mac when you did it?
It's a Windows application.
Oh.
Yeah.
It's a headache.
Yeah, it's the ugliest website you've ever seen, too.
Yeah, I can show you that.
But he's got directions here on how to install WebGL. And I've also linked a special version of MoloGoGo that I had the developer compile for me that has some additional stuff, like it will always post the coordinates to the cell tower. So with that information, you can actually build a coverage map. Just by driving around your town, you can figure out where you get the best signal and where all the cell towers are. And then I've also made a VXML application that connects to my database, so I can open this up in Google Earth and feed it this URL, and it will actually track me almost real time in the Google Earth application. It keeps refreshing the XML and then updating the Google Earth application.
Why do you say VXML?
I'm sorry, KML.
Thank you.
Yeah. Let's see, here's my map. This is a Google map I put together.
That's the Antarctica.
Oh, there we go. So, there we go, that's where my battery died on my phone. Yeah, so it's still there for me to turn it. And then here is, I've zipped up the special version of MoloGoGo, and it works on the i415, so if you guys want to download that from me, it's got all the extra stuff. And then here's a Google tutorial on KML, and then the API for Google Maps. So you guys can write your own Google Map applications. So This is inexpensive, $50 phone. If you guys want to run out to the store and get some this week, talk to me or Opus, and we can load up your phone with all the software you need, so you don't have to wait on the data cable. Yes?
What type of data are they using? GPRS?
It's an iDEN phone, so the data speed is about 56 kilobit. You can actually plug it into your laptop and get online with the phone and use it, you know, in, I guess, an extreme emergency when you want your latency to be horrible. SSH session.
Right, so it's J2EE compatible?
J2ME. It's actually, Motorola just recently released an open source development kit for these phones.
All right, so you get data, you get GPS. What kind of GPS?
It's a real GPS in the phone. It's got a separate receiver inside the phone that has a real GPS. In fact, I believe you can even turn on the GPS so it spits out the coordinates out your serial port in NEMA formatted data.
It's only 6.
All right, so wait, so I can just use this thing as a GPS. Why the heck do I want to use it as a phone?
Well,
I mean, sure.
it's not the
Actually, I never even talk on this phone. I just keep the phone in my car to, you know, track my car.
What was the cost for the new one? Cheap low jack.
20 cents a day.
20 cents a day.
Yes, 20 cents a day, so it's about $6 a month for unlimited internet.
So what about phone service?
I have no idea. I don't use it.
Phone service is terrible. It's iDEN.
Oh, okay, so it's nothing to write home about?
There's also another nice little hack I found with these
But
things.
for 20 cents a day and GPS is pretty.
Well, I mean, come on.
When you get the phone, you'll want to subscribe to their data service. When you sign up on their website, you check the little box that says I want data service, otherwise the application's not going to be able to send its data. But then you can go under their little web browser and go to search and type in I am slow, and all lowercase, and hit search. And it's going to bring you to this website called TechWap. You can go down there and do a net alert to your phone. It's going to send you a little message to your phone. And you store the message on the phone. Do not delete it, because every time it stops working, you have to go and play it again. And it reconfigures the phone to use their WAP server. Then you can call up Boost and cancel up the 20 cent a day internet service and use the internet for free.
Well, you used to be able to.
No, it still works.
Oh, wait a minute, so you're canceling the web?
Oh, no, there's so much stuff out there that works similar to that.
All right.
Any more questions?
Yes.
Is that the only brand phone that has a built-in radio?
The Nextel phones have the GPS.
Okay.
If you think about it, it's $50. You get like GPS
Yeah.
in a lot of phones. But
Yeah, I've got a Pelican case, the Pelican 2000 case. This phone fits in it perfectly. It's a crush-proof, waterproof case the phone fits into. And then you can use the light bar magnets from like the police car light bar things they stick on the roof of their car and attach them to the Pelican case and like stick it to the bottom so it's a car. They're like James Bond traffic lights.
Plus, you can call that solar. This is GPS what you stick under a cup.
It actually, the application will fail over to use a cell tower for location if it can't get GPS data. So it'll actually give you the coordinates to the cell tower if you can't get GPS data.
So it's actually a really good way to do low jack.
Yeah, I guess you can hardwire it to your car so that it's always
Yeah,
powered.
exactly. You can hardwire it so it's always powered in the car. You know, and just add an extra stick it lighter down and stick it in the trunk or something.
What I really want this to do is hook it into my car's onboard computer. Because if I can push and pull from my car's onboard computer, then I can start doing things like loading my MP3 player in my car when I'm parked in front of my house.
Okay, I'm going to carry on now. Thanks for that. And that's very cool. We'll be hearing more about that. And as we said before, I'll get Jason to mail out the links. Let's invite up Martin Steinman now from Opposite Foundry.
All right, thank you.
Simon. I was part of the original team that founded SIP Foundry about 2.5 years ago. Happy to be here. I unfortunately missed Cluecon last year, but happy to be here. Just got here actually. And thought I would give you a quick overview of what SIP Foundry does, and specifically what the SIPX project looks like, which is one of the main projects currently running on SIP Foundry. But I want to make it really clear that SIP Foundry really is an open platform where SIP-related, or maybe even general VoIP-related open source development can take place. So we're open for new projects. We have been for a long time. We have tried to improve our infrastructure, and there is a bigger infrastructure cutover happening next week. But we're open to other projects if someone thinks that they would profit from getting posted on SIP Foundry. We would be happy to look at them. So with that, let me get into SIPX. I don't know how many of you have actually looked at SIPX or have even tried SIPX. Do I start totally from the ground up here, or so there's some limited knowledge? Okay, so SIPX is, in very simple terms, yet another SIP-based IP PBX. The word PBX is a bit misleading. It's something a lot of people understand, but it's really much more than a PBX because it's much more than just voice. But for simplicity, we keep calling it a PBX. It's built as a distributed system, strictly following the SIP standard, and I'll talk about this a lot more during this presentation. We at SIP Foundry, and specifically also the people inside the SIPX project, know SIP really well. We have been there from the very beginning, participate in the IETF standardization effort, and also are very active in SIPIT events where the pieces of SIPX, the stack, the whole solution has been part of SIPIT since inception, I believe. We have a pretty rigorous development model with coding standards. We strictly believe in unit tests and other quality measures, and tend to use modern tools and languages, but we are very open to accommodate contributions and people who want to work with us as long as some of these rules are met. We work with the community to maintain a roadmap that is kept to commercial standards, and I'll give you an idea of how that roadmap looks like in a couple minutes. In general, there are no stupid questions on our mailing list. We really try to accommodate anyone. The traffic has increased quite a bit. There is an active community around SIPX TAPI, which is our SIP user agent SDK framework. And also SIPX has taken up quite a bit recently with quite some nice growth on both the mailing list as well as specifically in our documentation wiki. But there really are no stupid questions, there are only stupid answers on that mailing list. And we try to keep things open and modular, allowing you to just use components. So SIPX consists of a lot of components, as you will see during this presentation, and you can use the whole solution, but you can also just use a component, or you can contribute just a component, which is just fine. So let me start giving you an idea of a rather large deployment, just to sort of set the stage of what has been done to date with this. We're going to announce this probably in the next couple of weeks. Unfortunately, I can't give you the customer name. But this is a production deployment here in the US on the West Coast. And you're up to roughly about 4,100 phones. The total deployment is going to probably get to 5,000 hard phones, and it's all Polycom phones in this case. And then there are today already a few hundred soft phones growing. And the whole system runs on a fully redundant two-server implementation of SIPX, as you can see over there. So it's two redundant call control systems. And then we split the media server and the config server into a third machine. The PSTN connectivity is done through Cisco gateways in this case. And as I said, the system here is load balanced and will gracefully fail over if you pull the plug on one. And I'll talk about this some more too. So some of the nitty-gritty problems that we found in installations like this, for instance, is when you have a power outage at this company and all the phones and everything go down and then power comes back up, what happens is that every phone tries to register, tries to subscribe to message waiting, tries to retrieve its profile and do some other nasty things, which, right after power comes back leads to a huge surge. And the proxy registrar call control component has to somehow gracefully handle that. But the real problem is that as you do that, and all the phones have registered roughly at the same time, in about half an hour they will all come back and re-register. So somehow you can't do that, because if you have these huge peaks, then the system really becomes unstable. So one of the things we did here is handle that gracefully, so that the proxy registrar automatically will distribute re-registrations over time, so that they happen in a sort of well-distributed way. So that's just one of the issues that you will encounter when you kind of do deployments like this. And I'll get into some more examples like this as we go along. But why did we actually start over, and why did we come up with yet another PBX? I think we had some very specific design objectives as we went into this, and those design objectives really split into a user part and a developer's part, and they're sort of equally important to us. On the user side, we felt from the very beginning that we had to create something that is really easy to install, maintain, and use, both from an end-user perspective as well as from an admin perspective who might not have all the knowledge about voice over IP that's in this room. We wanted to create something that is standards compliant and interoperable, can work with any phone as opposed to a Cisco or an Avaya system. We wanted to have something that works with any phone, any gateway, as long as it follows the SIP standard. We wanted to take a holistic approach and not just create a server-side solution. We wanted a system that is holistic in the sense that all the phones and all the gateways are part of the system, so that you end up with a plug-and-play environment that you can plug in a phone and it will find a profile. That all the phone config, all the profiles and everything is centrally created, centrally backed up and maintained. So we had a holistic approach on this. We wanted something that is field upgradable, so that once it's in service you can actually gracefully upgrade and you understand that it won't break the system as you do so. We were very focused on stability in production environments and tried to create something reliable, and that all goes back to testing at the end of the day. It starts with unit testing and then goes into regression, stress testing, and functional testing in an automated way. And then we were aiming at full IT integration into LDAP, integration into web services with SOAP, integration into other parts of the IT infrastructure. So that's the user side of things. On the developer side of things, we really wanted to build a SIP application the way the SIP standard originally was intended, something that clearly separates media and signaling and is really built the way that SIP was designed. It's a distributed and scalable architecture. That was very important to us. Use of modern development tools and technologies, extensive use of available libraries, specifically open source libraries in this case, web services integration, standard communication between components. So the SIPX system consists of a variety of servers, daemons, components, whatever you want to call it, and we wanted standard TCP/IP-based communication between these components. We wanted an integrated unit test framework and automated regression and functional tests. So if I go and quickly run down the architecture of this and what the main pieces are it consists of, then we start out with what we call the call control system. And the call control system consists of 5 independent components. These 5 components communicate among themselves using SIP. They can be on one server hardware, or you can distribute them across several systems. Right now we typically run them on one server, but there's nothing that would inhibit you from distributing this. In the middle we have a forking proxy server. That's the SIP router that routes all the SIP messages in and out of the system. The registry redirect server then does the phone registrations, but also includes the dial plan and determines the routing of calls. Then the authorization proxy server handles calls that need to be authenticated so that the system can define permissions. One user might be allowed to call a 900 number, another one might not. And the authorization proxy server handles all these permissions based on sets of credentials. Then we have a presence server that right now is primarily used for agent sign-in, sign-out from our call control system. But we're working on a simple extension so that in the first approach we'll handle busy LAN field features as it was specified in the very last IETF meeting, I think. It's going to be based on the latest firmware revision from Polycom 2.0, which is coming out next month into GA. And that presence server then will be successively extended into a more comprehensive, simple-based presence framework. The status server down here is a subscribe notify server that primarily serves the purpose of doing message waiting indication today. So these are the 5 components of the call control system. On top of that, then we have a configuration server, and that configuration server is written in Java, and it's a comprehensive application that holistically controls the whole system. It controls the call control system, all the other servers that are part of the system, plus it controls all the phones and gateways. And I'll talk some more about this later. But it essentially has a web admin interface. It has a Postgres database that holds all the data, so there are no config files. Everything that's configured, including the phone profiles and everything, is in that database. And then it can serve profiles using TFTP or FTP to phones. And I'll come back to that and talk some more about that. Then down here we have a media server that does voicemail and auto-attendant services. And this is really the first component that touches the RTP media stream. The proxy part, the call control part, does not touch any of the media components. But the media server obviously does. Then down here there's a call park server. Again, that's an independent piece of software, an independent server that can run on the same machine or could run on a different machine. We're currently working on 2 additional components. One is a conference bridge that we once started in cooperation with the Reciprocate team called Boston Bridge. I think the status of this right now is that we feel we need to start that over and base it on the ZipX stack and fully integrate it into the system. So that's work in progress. And also a back-to-back user agent is something that a lot of people requested for some time. And I hope we're actually finally going to get there to add that. And then, last but not least, there is a complete ACD call center server down here, which unfortunately right now is not available in open source. And the reason is not that we wouldn't want to make it available in open source. The reason is that we developed this specifically for a customer under contract. And these guys just don't believe in the open source model and didn't allow us to put it out right now. But that will expire at some time, so we will be able to put it out at some point. So that's the architecture of the system. And I'm going to run you through some of the capabilities and features in the next couple slides here. So the first is the high availability configuration that I touched on in this deployment example. So essentially what you start out with is 2 systems that can be in the same data center or could be in different geographic regions. The load balancing is based on DNS SRV records, and the metric of how you actually load balance is specified in the DNS server, obviously. When an invite comes in or a phone registers, the DNS server decides what are these ZipX proxy servers it goes to. The 2 servers are fully synchronized using XML RPC, so that the state information is synchronized between the 2. So when you have a phone, the phone can register with either, and it's actually really, by accident almost, it might register with ZipX 1 or 2. The registration as it occurs is replicated to the other system. And when you then collect call detail records, then obviously those call detail records need to be collected from both systems. But the redundancy really works in a way that when a call initiates on one server, you do an invite and you're in a conversation, and now you want to do a transfer, but in the meantime, the server you actually used to set up the call died and went away. Then as you initiate the transfer, it will seamlessly fall over and the transfer will be handled by the second system. So you're not going to drop the call, you're not even going to know that there's a system outage that occurred in the meantime. So that means the perception you get from a user perspective is that this is one large system, so there are no dial plan tricks where you say that with prefix 3 I go to this system and with prefix 4 I go to that system. It's literally one big system with one routing plan. It load balances under normal operating conditions. It has full proxy registrar redundancy, and it has error condition handling for CDR collection when one call starts on one system and then continues on the second. And it's not a cluster, so we don't need clustering technology underneath. The load balance is like an Apache web server with load balance. By the way, if there are any questions in the meantime, I'm happy to jump at those.
So
okay.
You said they handle transfer. Do you
you act as generally as a proxy or do you be away?
Well, you know, we're a proxy, right? So that, yeah.
If you do a transfer, you're not in the call next, are you?
Yes, we are.
Okay.
Because signaling goes back to the proxy, so all the signaling information goes through the system.
How does it, you put a report route in, or why would you have to do that?
Because the phone is set up to do that. So the phone would, by default, you know, send, so usually we set it up with DNS SRV, right? So when a phone sends a message to another phone, then, you know, the system that handles SIP requests is defined as an SRV record and always goes back to the proxy.
Well, that's for the initial call, but once it's connected, is it going to send future requests directly to the other one?
No. No.
Basically, you can record, in SIP, you can always record route it so you force the messages back through the proxy. That's the trick. That's basically what they're doing. So.
Yeah, and I'm happy if you guys help me out on the details of the technology because I'm the least technical guy in the SIP Foundry board.
Basically, it does a SIP record route which forces all the follow-up requests to go via proxy instead of direct.
That does a record route then?
Yeah.
Okay.
So you said you were using XML RPC to sync like registration state.
Yes.
Are you also syncing call state between the two?
Yeah, everything that is call state, there is, you know, there's some state information, but not that much. So essentially, in this case, the proxy is stateless, but the state information is in the registrar. So the registrar is synchronized in real time with the other system.
So how do you accomplish a transfer then at one of the original node this time?
Well, the transfer is accomplished because it uses DNS SR. You mean how it actually finds the other system now?
No, how does it know it's a transfer and not a new call?
Well, see, I think, you know, you guys are losing me here. I can't go all the way down to the, you know, the details of the SIP protocol, and I apologize for that. I'm just not, you know, technical enough to do that. All I know is that you have the DNS SRV system set up in a way that it does lookups through DNS SRV, and therefore it will just fall over to the other system like as nothing happened. Because every time you send a new SIP message, it will do a lookup of where it needs to go, and if the server is dead, the DNS server will just fall over and give you the other one.
Yeah, I guess I understand that part, how it finds the failover in the backup server. Just wondering if you had to maintain any knowledge that that terminal was involved in a call on the backup server so they can take over seamlessly.
I don't think you do, but that would be a great question for the SIPX users list, and I'm sure you would get a very detailed answer. I just can't answer that question. Sorry. All right, so let me move on here before I get into more trouble. So this is the example of call detail record data collection and processing in a, you know, first non-AJ case and then in an AJ case. What we collect really is what we call state events, and there are lots of call state events in a call, or at least there could be lots of call state events in a call, because as you do transfers, as you park a call and retrieve it from park or do other funny things, you create a lot of call state events. And these call state events are stored in a Postgres database on the server itself. They're then collected by a process called call resolver that can be on the same system or a different system, and post-processed to generate call detail records per call that includes all the information of what actually happened to that call. And if you have a redundant system here, then these call state events can be distributed and reside on both systems in two different databases, and therefore the call resolver process is going to collect call state events from both ends and combines them into CDRs and puts those CDRs back into a database. Does that make sense? Okay, so we believe that this is a performance-optimized CDR data collection and processing method. It supports AJ config, all data is always in the database, and it allows you to do offline CDR processing, which means it doesn't load the server while you're in a peak load scenario. Now I have a slide here on performance, and this is sort of slightly dangerous grounds. because talking about performance is always a very dicey subject, since performance is extremely hard to measure unless you exactly define what the test case and what the actual scenario is. So I'm not going to, claim that any of these numbers work under any specific condition, other than saying we did extensive tests and tried to at least produce some numbers that give you an indication of sort of what some of the parameters are that we looked at. Now, one of them obviously is sort of how many calls per second or per hour you can actually get through the system, and this is not, like a server router that does thousands of calls a second, right? This is a system that consists of a variety of components and does all the PBX signaling. But we believe that the current performance on calls per second is absolutely perfectly sufficient for what the target application is this. And then you can see that we looked at number of re-registrations, number of subscribe, notify, number of users for the system, and that's primarily when you look at config server, you have a search function in there. How many users can you have in there so that the search performance is still sort of bearable for the user, that when you search for a specific user, you actually get a result within a tolerable time frame, things like that. When we talk about virtual media server ports, we talk about number of gateways, and because of the architecture of the system, there really is no limit on how many gateways or how many simultaneous calls you support on the system, since media really doesn't go through the system. And then you looked at number of CDRs processed an hour. Okay, so without getting into a detailed argument about these numbers, I just wanted to kind of give you an idea of what we test and measure and sort of how it roughly looks like. I think we talked already quite a bit about why media does not go through the proxy. The only case where media hits our server is when you call the media server or the part server or some other server that actually carries media. But under normal operating conditions, media does not go through the system. And that has some distinct advantages and then has some difficulties that make the system design tougher. The advantages are that it supports unlimited number of calls. It supports better voice quality with less jitter and less delay. The codec negotiations between endpoints, it supports all media. You can connect the video phone and you would care less. The HA failover works without disconnecting the call, but you cannot use DTMF tones for feature invocation. So sometimes it would be easy to create a feature where you can just sort of dial star something and it would do something. Now there's nothing that would listen to those DTMF tones. You have to actually signal everything in SIP. And also, the whole problematic of NAT and firewall traversal is a bit tricky because media now is separate, chooses its own port, and you guys know that problematic a lot better than I do. But that's the way we have designed this, that media does not go through the system. This is config server and some more details on some of its interfaces. I think we already talked about the fact that it has a Postgres database and is a comprehensive config system for phones, gateways, and the system itself. It supports, from an external interface perspective, an LDAP upload capability, and we have done quite a bit of testing on Open LDAP, and the testing on Windows Active Directory is still in progress, but it should work on Windows. Then we have an import capability from Excel, so if you go to someone who wants to install this, you can create a spreadsheet that includes all the information about my users, names, extensions. You can put all the phones in there, the MAC addresses of these phones and everything, and do a proper planning and discuss it at the site. And then you can upload that Excel spreadsheet file directly into config server, and we'll create all the users' phones and assign the lines to the users or the phones and everything. There also is a SOAP web services interface that is bidirectional, so it can import and export, and that's primarily used to integrate this into a portal if you want to sort of remote control this. From a phone perspective, it generates profiles for phones and includes all the config user interface for phones, so that the phone's user interface really is not needed at all. All the parameters that you can configure in the phone are configured remotely inside config server. And the big advantage of that is that it generates default profiles with only very minimum input that create workable profiles, so that the phone will come up with a line assigned that registers that you can actually make a call. Then it talks to the system components, either using the file system if it's on the same machine, or it uses XML RPC, and we primarily use this with our ACD server today to communicate with XML RPC. The latest addition to this is OMA DM, which is a standard out of the mobile world that allows us to configure dual mode converged handsets, so that when you have a Wi-Fi phone with a SIP client, you can over the air using OMA DM, which is a similar protocol to SyncML, project a profile down to that phone, so that the phone then takes the identity and becomes a device on that respective system. These are the phones we currently support from a remote management perspective inside Config Server. You can use any SIP phone that is standard compliant if you configure it manually, but these are the phones that are configured plug and play from within the system, and we try to accommodate sort of full product lines from specific manufacturers. There is the Hitachi cable Wi-Fi phone is currently being added, and there are some other phones that I heard that some people are working on. But this is what we currently support out of the box. Oops. This walks you through how you actually add a new user and a phone. So if you have someone join a company and you need to add a phone and a line. So the first thing you do is you take the phone out of the box and you enter its MAC address into the system, and you choose a phone model, in this case a Polycom IP4000. And these two parameters are the only two parameters you would enter, and with that you have created an instance of that phone. You then create a user by giving the user a user ID. You enter name, first name, last name, extension number. You can put that user in a group where the user would inherit some group properties like permissions and other things. And after you've done that, you would assign that user to the phone simply by saying that user, the line that corresponds to that user, is now assigned to that phone. The system automatically generates a profile, and you now go and plug the phone into the wall. It will get the TFTP server address through DHCP, pick up the profile, and come up configured. So it is centralized plug-and-play management, all phone parameters configurable in Config Server. There is no need for the phone's config interface. Default parameters generate a working profile, and all phone config is stored and backed up centrally. So when you back up that Postgres database, all the phone config in your entire enterprise is backed up at the same time and can be restored from there. Adding a gateway is slightly similar. We're still working on actually completing the first fully configurable gateway in this system. We have a beginning on audio codes, and we're working on pattern gateways. This is, to an extent, work in progress, but it works the same way. You take the gateway out of the box, you enter a MAC address, its IP address, choose a gateway model, and then you go into the dial plan, you create the dial rule, add that gateway to the dial rule, generate a profile automatically, and then the gateway would pick it up and it's configured. So first gateway supported will be audio codes and pattern. We have centralized plug-and-play management for gateways, all gateway parameters configurable in the config server, no need for the gateway's config interface. Default parameters generate the working profile again, and the config again is backed up centrally in this Postgres database.
So back on the previous slide with the phones, when the phone, do you need to pre-provision the phone to know where to request its TFTP download?
No, you typically don't. You typically get that through DHCP. So you set up the DHCP server to give you that address. Yeah, so the idea is that you can literally send these out even to branch offices, and people can just plug them into the wall, and all you need to do is know the MAC address of the device. Yeah.
So it's a DHCP option then where it gets the TFTP?
Yeah, exactly. Yeah. It's option 66, I believe. Okay, then this one here, least cost routing and failover. You guys might be familiar with this, so let me, bear with me as I walk through this. So in this example, you would have a headquarter with, a SIPX proxy registrar system installed and the dial plan. You would have a remote office, and in that remote office, you have a gateway. And let's say headquarters is London and the gateway is in Boston. And as this phone makes a call to a London number to get the dial plan, would obviously least cost route and choose the gateway in Boston to terminate that call. And audio then is established between the phone and that gateway. If, for whatever reason, the internet connection does not exist anymore, is down or broken, if you have phones in that remote office, they can be configured so that they can place emergency calls and other sort of simple things directly through the gateway, or you could co-locate another SIPX proxy here that can be either an independent system, or you could couple it and run it as a J, sort of as one big system. If you now have a second office in New York and that guy in Boston calls a number in the US, but the gateway in Boston is busy, it's either not available or all the lines on that gateway happen to be busy, then the system automatically fails over and terminates that call on the New York gateway. So the dialing rule includes any given number of gateways, and if the gateway is busy, no more lines available, or you just can't get to it, it will simply pick the next gateway in the line and route the calls through that. So you have some nice gateway redundancy in this picture. And then we had a lot of discussion on SIP trunking options and how you actually do this with SIP properly. And I think this is one of the areas where SIP still is kind of not fully up to speed. The most normal scenario is that people use a Cisco firewall, a big or a small PIX or whatever, and as hard as Cisco tried, the PIX still can't do SIP. It can do some SIP, but really it doesn't work. And therefore, if you want to do SIP trunking to either get to a service provider or have remote workers who register their phones remotely to your SIPX system on the inside LAN, or you want to make calls to other enterprises using a SIP URI, then you really need another mechanism than a PIX firewall. And the best ones we have found to date is either an Intertex IX67 or an in-gate box. And I guess over time the industry will catch up and figure out how this really works. But today, if you use either an Intertex or an in-gate box, it's actually a perfect solution that really makes sense and works. Now, a lot of companies have trouble deploying it this way, essentially replacing the Cisco PIX. They're concerned about security and how this works. And therefore, alternatively, you can deploy it this way, where you use them in a so-called separator setup that is a one-armed connection that only sits on the LAN. And in this case, this Intertex or in-gate box does all the mapping required so that the call and all the SIP traffic and the RTP traffic and everything else will actually go through a standard PIX without any trouble. All you got to do is open a few ports and map them back to that in-gate or Intertex box. Okay, then I think we had quite a bit of focus. I talked about the fact that we wanted to have a system that is simple to manage, a system that is easy to use. So we looked a lot at how you actually install this with an automated single CD install, how you do backup and restore, how you do field upgrades, how you reset to factory defaults once you have this deployed. And I don't want to really go into too much detail here. I think this is too high level a slide for you guys. But just to kind of give you an idea that as you deploy these things, these are questions and issues that inevitably will come up. This is our current roadmap, and a year ago when we were here at Cluecon, we were talking to you about our release 2.8, which in hindsight really was a fairly incomplete system. And I think since then we have made quite a bit of progress. We released release 3.0, 3.2, and just last week 3.4 became GA. Currently working on